Elastic collision. This article needs additional citation for verification. Learn more. In physics, an elastic collision is an encounter collision between two bodies in which the total kinetic energy of the two bodies remain the same. In an ideal, perfectly elastic collision, there is no net conversion of kinetic energy into other forms such as heat, noise, or potential energy. During the collision of small objects, kinetic energy is first converted to potential energy associated with the repulsive or attractive force between the particle. When the particle move against this force, the angle between the force and the relative velocity is obtuse. Then this potential energy is converted back to kinetic energy when the particle move with this force. The angle between the force and the relative velocity is acute. A useful special case of elastic collision is when the two bodies have equal mass, in which case they will simply change their momenta. The molecules, as distinct from atoms of a gas or liquid, rarely experience perfectly elastic collision because kinetic energy is exchanged between the molecules. Translational motion and their internal degrees of freedom. With each collision at any instant, half the collisions are to a varying extent. In elastic collision, the pair possesses less kinetic energy in their translational motion after the collision than before, and half could be described as super elastic, possessing more kinetic energy after the collision than before, average across the entire sample. Molecular collisions can be regarded as essentially elastic as long as Planck's law forbids energy from being carried away and blackbody photons. In the case of macroscopic bodies, perfectly elastic collision are an ideal, never fully realized but approximated by the interactions of objects such as billiard balls. When considering energies, possible rotational energy before and or after a collision may also play a role. One-dimensional Newtonian. In an elastic collision, both momentum and kinetic energy are conserved. Consider particle 1 and 2 with masses m1, m2 and velocity u1, u2.